Hello, everybody. My name is Leah Husseini, and today's date is February 6th of 2026. And for my biochemistry final project, I chose to present on nutrients, vitamins, and minerals. And this presentation is going to focus on the biochemical role of vitamins and minerals and why deficiencies can or excess intake can lead to disease. To introduce, vitamins and minerals are essential for micronutrients and are required in small amounts but are also critical for health. And they also support metabolism, growth, and cellular function. Both deficiency and toxicity can cause disease, and balance and variety are diet for key. And even though these nutrients are needed in small amounts, they also play a huge role in keeping metabolic pathways running normally. And right here is an image of a healthy eating plate. Micronutrients versus macronutrients. Macronutrients are carbohydrates, proteins, and fats. Those provide energy. And then micronutrients are vitamins and minerals. They do not provide energy in regular biochemical reactions. And micronutrients act as cofactors and enzymes. And in this diagram, you can see that there are six essential nutrients: carbs, fats, and protein. Those are macronutrients. And then water is water. But then the micronutrients are vitamins and minerals. So while macronutrients gives us calories, micronutrients basically make sure those calories can actually be used properly at a cellular level. Vitamins overview. There's organic compounds which are required for normal metabolism. There's two different categories. There's water soluble and fat soluble, and those key functions are coenzymes, antioxidants, and gene regulation. Most vitamins act indirectly by helping enzymes function, which is why deficiencies often affect multiple body systems. Water versus fat soluble vitamins. Water soluble conclude with B complex vitamin C. They are not stored intensively. The excess excreted in urine, and deficiencies develop quickly. While fat soluble include vitamins A, D, E, and K, which are also stored in liver and adipose tissue, which also causes higher toxicity risk. And right here is a diagram of the vitamins explained, water versus fat solubles. And this difference is really important clinically because fat solubles vitamins can build up in the body while water solubles fats don't. B complex vitamins primarily are involved in energy metabolism, act as coenzymes in metabolic pathways. The deficiencies often affect the nervous system, the skin, and blood cells. And that's why B vitamin deficiencies often show up as neurological symptoms or skin changes. Key B complex vitamins. There's B1, thiamine, energy metabolism. The deficiencies, and there's berberine, Wernicke-Korsakoff. And then there's B2, riboflavin, FAD, and FMN, which are the deficiencies are chiliasis or glossidiasis. There's also B3, niacin, NAD plus, and NADP plus. The deficiency is pellagra. There's B5, pantothenic acid, which is coenzyme A. B6 is pyridoxine, amino acid metabolism and neurotransmitters. B7, biotin, carboxylation reactions. The deficiencies are raw egg whites. And there's B9, folate, the DNA synthesis. The deficiency of that is megaloblastic anemia and neural loop defects. And B12 is cobalamin, which requires intrinsic factor. The deficiency is neurological symptoms. And each B vitamin has a specific role, but they will all work together to support metabolism and nervous system function. Vitamin C. It's antioxidant. required for collagen synthesis, and it enhances iron absorption, which the deficiency is scurvy. And these are the types of citrus fruits that we intake. And then vitamin C plays a huge role in collagen formation, which also explains this why scurvy causes poor wound healing and bleeding gums, for example. Fat-soluble vitamins overview. Absorbed with dietary fats, stored in body tissues, and excess intake can lead to toxicity. Because these vitamins are stored, excessive supplementation is more dangerous compared to water-soluble vitamins. Vitamin A, vision, retinal cycle, epithelial cell maintenance, immune function, and deficiency night blindness. And the visual symptoms make sense because vitamin A is directly involved in retinal cycle. Vitamin D regulates calcium and phosphate, bone mineralization, and activated in liver and in kidney. And the deficiency is children get rickets and adults get osteomalacia. And vitamin D acts more like a hormone than a vitamin, which explains its widespread effect on bone health. Vitamins E and K are vitamin E is antioxidant protecting cell membranes, but the deficiency is hemolytic anemia, and vitamin K is activations of clotting factors, which the deficiency is bleeding disorders. And the vitamin E protects cell membranes, while vitamin K is essential for normal blood clotting. Minerals overview. Inorganic elements, structural and regulatory roles. There's two different categories, major minerals and trace minerals. While electrolytes like sodium and potassium are especially important for nerve conduction and muscle function, while the mineral while the mineral my apologies, while mineral overview of that are just as important as vitamins because they're inorganic elements rather than organic compounds. Major minerals, calcium, bone health and signaling, phosphorus is ATP, which is energy, and nucleic acid. Magnesium is enzyme cofactor. And then there's sodium, potassium, and chloride, which those give fluid balance and nerve production and nerve conduction. And electrolytes like sodium and potassium are essentially important for nerve conduction and muscle function. And trace minerals are iron, oxygen transport, deficiency of that is microcytic anemia, zinc, immune function, and which causes also wound healing. And then iodine, thyroid hormones, the deficiency of that is the goiter. And the selenium is antioxidant. And then there's copper, magnesium, fluoride, and those are all three are metabolic and structural roles, which even though these are needed in very small amounts, deficiency can still cause serious health problems. Clinical applications. Toxicity risk with fat-soluble vitamins have high-risk populations. Pregnant women, elderly, alcohol use disorder, and the supplements are helpful when deficient or harmful when excessive, and the drug-nutrient interactions matter. The clinical applications. This is why supplementation should be targeted and not taken excessively without medical guidance. And to conclude, vitamins and minerals are essential for life. They support metabolism, growth, and cellular health. Both deficiency and toxicity can cause disease, and balanced nutrition is the best approach. And overall, maintaining a balanced diet is the safest way to meet micronutrient needs. And now I have some multiple choice questions. Which vitamin requires intrinsic factor for absorption? A, vitamin B6, B for vitamin B12, C for vitamin C, and D for vitamin D. Take a second to think about it, which option best fits the biochemical role we just discussed. Vitamin B12. And this question highlights how micronutrient deficiencies present clinically. Number 2, which vitamin deficiency leads to scurvy? A, vitamin A, B for vitamin K, C for vitamin C, and D for vitamin E. Correct. Vitamin C. This question also highlights how micronutrient deficiencies present clinically. Which mineral is a key component of thyroid hormones? A, iron, B, zinc, C, selenium, or D, iodine? And take a second to think about it, which option best fits the biochemical role we just discussed. Correct, iodine. Number 4, fat-soluble vitamins differ from water-soluble vitamins because they A, are excreted rapidly in urine, B, are not stored in the body, C, have a higher risk of toxicity, or D, provide energy. Now take a second to think about which option best fits what we just previously discussed about. Correct. Have a higher risk of toxicity. And number 5, a deficiency in folate is most directly associated with A, night blindness, B, microcystic anemia, C, megablastic anemia, or D, hemolytic anemia. Now take a second to think about which option best fits the biochemical role we just previously discussed about. Correct. Megaloblastic anemia. Thank you so much, everybody, for going through this presentation with me, and I hope you learned as much as I have.